the stream is working. Everything says it's okay on my side. If you guys can hear well, please leave a message in the chat. So everything is fine. Okay, thank you, Maud. We'll wait for a couple of minutes and then we can start up for now. The plan today is to continue working on parsing more expressions and specifically Boolean expressions. And by that I mean parsing Boolean literals and also parsing like comparison operators. And if we can, we'll go on and parse more statements. Well, specifically, the plan is to parse in block statements, which will allow us to parse conditionals. And it will also allow us to move on and parse groupings of statements such as blocks, such as functions, so to say, and for loops. So last time we added like a bunch of tests via this visitor interface, and we are now able to do like math expressions of some sorts, and we handle priority very well. Also, we are able to parse in like a bunch of statements such as declarations and return statements. But for now, this can't even make a small program. So we wouldn't have to need like we need to add a little bit more of functionality to make like a basic language. Not all the features that we want to implement yet, and we will need to add some kind of feedback by like implementing some sort of REPL or something similar. All right, I guess with that, so let's start. So as I was saying, we started with the we left off on parsing return statements, and we saw that everything passes quite well. And today the goal is to start in trying to parse Boolean expressions. And with that, let's start doing that. So we will do the same as we did before. I'll just try to copy this function. And then let's call in parse Booleans. And the test structure would be the same. So we have like true, and we expect a Boolean literal with the value, with the actual value set to true. And I guess we'll do the same again for a false node, and we'll expect this to be false, right? For now, nothing will work. I'll have to remove these somehow. Yeah, and this should stay the same. So this doesn't compile yet, so let's create these types. We created them in the node file. So let's create a func, not a func, let's create a type. Let's call it a Boolean literal to the struct that has an actual value, which is a which is a Boolean, and it has some kind of token. And this doesn't can help during debugging, but it can be omitted. So Boolean literal in itself is an expression. So we need to accept the visitor, so we can add like destin later. So we'll do like as we did before. We'll just call in visit Boolean literal. I guess v. And for the other ones, I'll just leave them as is. In this case, the literal would be like return b.token that value, that literal, I guess. And for the Boolean literal, let's add in that. So I want to group my expressions in the same, let's add it here. Visit Boolean literal. And then let's have a Boolean literal. This doesn't matter. This is not spelled correctly. Now I guess it is. Let's go back to our parser, implement a bunch of stuff. I guess we have two visitors we want to change. We would need to change the print in one. Yeah, so we would need to add and the literal would be like just p dot indent and p dot, I want to make it like at the bottom, and we want to do p dot buffer dot write string, and we do sprintf, and we call it a Boolean literal, and I just do. Did I name the literals as expression? Nope, I did not. So that's good. What's actual value? Right. Now let's do. Where is that test? It was in parser test, right? And only literal. I did two T's. And let's go back to this. Implement node visitor. So, all right. And to test, we'll do like current node. Actually, we'll do something that is, we just take the current node and assert on its value. So we have the expected. And now this should be a Boolean literal. And we assert that this works. And we assert equal t that the current node dot actually not the current node but the expected Boolean literal, that actual value should equal to literal that actual value. We want them to have like the same expected value. And yeah. And this is t.t. Okay, I guess the project now can build. Let's go back and like try and do something as, if we do a2, it will print as, let's see, it will blow up because there is no parsing function for this token. And that's for a reason, because we can't parse it for now. So let's go back to our function definitions. And then we have like some prefix functions that we define. And then we would need something as p.register function, register prefix function, with something such as parse Boolean. And we give it the lexer dot true and the lexer dot false. So whenever you find a true or a false, it's a good idea to delegate this to a parse Boolean, so we'll be able to parse it. Now let's define this. So parse Boolean should, in theory, it should take the current token and then create, so let's create a Boolean literal from, let's fill in the actual fields, and the actual value actually will depend, so let's return this for now, and the token should be the p.currentToken, but the actual value should actually depend on whether the, so if the token dot type is equal to true, so the actual value would be true, otherwise it should be false. I guess this should work. Let's try this out. And now we get in like a Boolean literal, which is true. And then if we change it up and say false, the actual value should be false, right? Now let's try to run our test. Yeah, so this is the newly added one. All right, and the test passes. Great. So this is like the first bullet of today's stream. The second bullet, I guess, is to implement logical operators, which is basically like implementing greater than, smaller than, or at least less than, and equals and not equals. I don't remember the tokens. So we had greater than, less than or equal, equals and not equals, and those all of those are kind of binary operations, or so we can like parse them as we did for the plus and minus. So those are prefix functions. And for binary operators, we would want to have a lexer dot greater than, lexer dot greater than or equal, lexer dot smaller than, less than, lexer dot less than or equal, lexer dot equal, and lexer dot not equal. I should break that line somewhere here probably. All right. So yeah, no questions in chat. Okay. So let's try and do these things. Let's do a... Let's go back to the test and try to write a couple of tests that does this. That kind of see if we can actually do this. No. So we should call logical operators. Not really. I'll call them comparison operators. And the expression would be like 1 is smaller than 2, 1 is smaller than or equal than 2. And this would be like a number literal expression with the actual value being an int 64 of 1, of 2, and a binary expression with operator be lesser dot less than. So did we create them using a... So we actually created a token, all right. Okay, and the test here is the same, but instead of a greater than, we have less than or equal. So let's try and run this, see what happens. It kind of blows up. No parsing function found for this. So probably so it broke. I didn't expect it to broke, but that's fine, I guess. Let's pass parenthesized, parse binary expression, parse internal. Guess I want this. Alright, so let's debug that test. See why it's not working. Alright. OBS stopped streaming for a minute. Sorry for that. So we were able to parse it. And then the left now is 1. And P, that next token is this one. And the current precedence, yeah, so we should probably give it precedence. So precedence of lexer dot less than is, it's probably, let's give it 1 probably. I'm still not sure about less than. I don't know if this will fix it. Because it should parse it in one go. Yeah. So now left contains an operator. Yeah. This was the issue. Let's go back to the test and try and run it. Yeah, we have some problems. So expected. Oh, really? Expected something and didn't get it. Why? Where is the Boolean visitor? I guess that's the cause of the issue. So that's cool. But how about binary operator? Binary expression. Okay, so we should set the literal, another type, and the literal is actually this in this case, and something different in here. Yeah, not the type, but the literal in here also. Now the test passes, so let's do the same for greater than operator. Now if we run the test, I guess it'll break again. Yep. Let's go back to the parser, add these here. So for all logical operators, we'll have the same thing. This is less than or equal. This is equal. This is not equal. Now this should produce the correct result. Surprisingly, no. Yeah, why do I have this? Yeah, wrong, copy and paste. Yeah, now tests pass. Now let's add the same test for comparison operators. Not equals and not equals. And yep, it breaks because I never update these. Good. Now these tests pass. Let's run the test for safety for the whole package. And all of our tests passes. All right. Just remove these because I never used them actually. Okay. Now let's think a little bit. How will this play out with parenthesized expressions and with other binary expressions? Because we want the order of evaluation to be kind of defined and expected. So let's do this. Let me try like a couple of cases. So let's say I want to have 1 is bigger than a, right? Plus 1. And let's say, so do we expect what we expect is like we expect this to be evaluated, then this. So the tree should be 1 is bigger than 2 plus 1, and not 1 bigger than 2 plus 1. And that was, and this is the expected behavior. So let's do this. So the tree generated should be like this. So the pre-order traversal will be like 1. The in-order traversal will be like 1. The operator, then the 2, then the other operator, which is 2, which is plus, then 1. And again, if we run this, yeah, it passes because we gave them the correct priorities. And this should like persist for everything else. So we should give it these, and yeah, of course, should do these. Yeah, and also we want that parenthesized, to make sure that parenthesized expression have priority. Now I would like to have a parenthesized expression and 1, then this one. Then the plus again. I actually can't imagine the tree. Yeah, let's write it out. But it still passes. Because like we'd have these, all of them before, then this one, then this one. We'll have the operator here, and then we'll have this expression, this expression, which means this one is better. I guess that's good enough, at least. What else? Yeah, so we tried with these. I don't know if you should add like other operators. It should be like a lot of tests for this, and it can become like a little bit cumbersome, so I'm gonna skip it because we covered the base cases. The lowest priority is plus and minus. Then if it works for plus and minus, it should work for multiplication and division. Or any other operator with a stronger precedence, so to say. So let's try and implement a block. Yeah, a block, as you can imagine, it's just a curly bracket and then an opening curly bracket and closing curly bracket and a bunch of statements and expressions inside. So let's start designing this. Yeah, so let's create another test for this. Let's just do a func test parser parse block statement. And then we'll create the source for this would be something like this. And we'll do, let's say, var a equals 1 plus 2, and then return a. And this is a block in itself. And yeah, using this would be like parser. So I'll just copy up the boilerplate for this. I'll copy the test boilerplate for me here because we'll know eventually we want something we want something like this. Let's start with one test. The expression will be, as I said before, var a equals a 1 plus 2, and then return a, and this would be our first block. And the idea is to have a block statement, which we don't have for now, and we'll have a bunch of declarations inside. So we'll have a declaration statement, and then identifier statement, I guess, identifier expression, and I guess this is a, okay, let me copy this over from one of the tests. So we kind of have tests for assignments. So we have a declaration statement. It says a number literal and a binary expression with a plus. Yeah, so this looks like it should do the job for this. Literal is a 1 plus 2 in this case. And another part of the block statement is return. I guess I returns the let's copy a return node, this one again. In this case, a return statement with a identifier expression, and the identifier expression would be how are we testing identifiers? Boolean declaration, yeah, identifier is by name. All right. And the identifier is name. So the missing thing here is the block statement, which I'm gonna create now. So let's do type block statement struct, and a block statement has a bunch of statements in it. Statements, right? And an array is like this. Let's implement a block statement itself as a statement. A statement doesn't have to implement anything in this case. The literal for the block statement would be, I don't know, block statement. I don't think we use this function really, unless for printing or debugging reasons. And the visitor would visit block statement. And yeah, visit block statement. I have another statement, visit return. I have a return, I have a declaration statement, yeah, it should be here. All right. Now let's go to our visitors and like rectify our addition. Not visitor. p.indent. And should print in the p.write buffer write string statement. Right, and we should add the indent, so that indent was equals indent width. Come on. And then do statement dot statements dot for I'll do p dot visit p dot accept what's my visitor, yeah, statement dot accept p, yeah, and this should do it for that. Let's go to the parser, to the parser test, and try and implement this as well, and do testing visitor, node visitor, and we know like it's gonna be the same, so let's see how are they implemented. Binary expressions, we have statements, right? Yeah, I'll just put it in here. I'll try to group things together. So when we're visiting a block statement, we will test that this is actually a block statement. And for each one of its statement, we'll do a block statement dot for dot statements dot for. We'll do a statement dot accept t, so that we can test it over. And yeah, now we know this will fail because we are not actually testing this. Invalid indirect of p. Yeah, my bad. This should have been a about now? Yeah, now it breaks because we don't know how to parse like stuff that starts with a curly. So let's teach it how. So our parsing prefix functions will say like p.register prefix function, p.parse block statement. Whenever you see a lexer dot a brace, I guess open brace. Right, let's create that. So let's create it here. So we know like the first one is gonna be a block statement. And the statements would be a statements. So the current token is so the current token is just one single curly brace. So I'll do like p dot advance, I guess. Advance expect lexer dot open brace. So does advance test on the current? Yeah, I guess that's it. And let's loop over for all of the next ones. So let's say while we don't have a closing, while p dot peak, let's see, like next token is different, that type, I guess, is different than Lexer dot closing brace, and p dot next token is different than that type again, and the file. So we want to keep parsing as long as we don't hit a closing brace or an end of file, right? And for that we want to do like current statement equals p dot parse statement, I guess. And if per statement is equal to null, for some reason, this means, okay, to-do, this is probably an error. Fix when error handling is added. Right. For now is just panic. And we'll do like statements dot equals state append statements to the current statements, and we'll do p dot next to advanced token. Actually, I'll just advance, not expect. Now, once we get out of this loop, we'll know that we are done. So if p dot next token dot type is equal to Lexer dot close brace p dot advance, or at least so if the current token actually here, so if the current token dot type it's not a closing brace, it's something else, so we'd want to parse this. And the current token. Now if the current token is a closing brace, I want to skip it. So if we get out of here with that, we advance and then we return the block statement. And the block statement dot statements should equal to statements. And this should return not an expression but a statement. This could probably cause errors. Yeah. Prefix function is something that registers binary parse function. This is a pickle. So we have statements are in fact an expression. Yeah, so if we change this by, what happens if we make here expression? What happens if we make statement and statement? So I'd say like a bunch of stuff need to change. We don't use expression per se. So when parsing expressions, we don't actually make a difference. It doesn't actually make a difference for us. or not do that. Probably let's keep them different, and let's remove that from here. If I remember correctly, we have a way to kind of mitigate this. We can remove this from here, and the function that kicks in the parsing is the parse statement itself. So we can say that we have a case when the lexer dot open brace will return p.parse block statement. That should be it. Right? So running this will probably blow up, or not. It actually didn't blow up. I'm surprised. I'm really suspicious when this kind of works from the first time. Run it. So let's see, var a equals 10 and var b equals 12, and let's return a plus b. What's the output of this? So you can see we have a block statement, we have a declaration statement that has a 10 in it, we have a declaration statement that has 12, and then we have a return statement that has a binary expression, which has an answer. Wow, this actually worked. So let's do this. This is the tricky part, I guess. A equals 1. How does this will turn out? We still have not, I don't think we did it, so I'll just keep it like this. Yeah, apparently nesting also works. What do you know? Yeah, apparently it works. Let's add a couple of tests and verify this. I'm actually still suspicious. Things never work out from the first time. So let's add a couple. So I have a var a. Now let's do a nested block, and then another nested block. So this will be a block statement, and then you'll have another block statement in here, and then the declaration of a equals a plus b, and then you will have another of the same, and then you'll have the return statement. Here it's b 1 plus 2, and then you'll have a return a plus b. Let's do a. Not this, but this actually. Oh yeah, so parsing found for. So did we mess something up? So this actually didn't work. Let's see what it prints. Let's try it out. Yeah, no parsing function found for this. That's bad. I knew something was wrong. But that's fine, I guess we can fix it. So what did we do? So all my function for parsing are why did I ever make this public? For some reason. So block statements in here should be empty. And let's see when it hits this, what happens. Yeah. So we have a block statement. I want to keep my eyes on the source. We have an open brace, and the current statement is a beat up parse statement. And if I jump, I just find another block statement. Yeah, I feel like I'm kind of looping somewhere. So what's the current token? The current token is an opening brace, so we would parse another statement. And we kind of take it. And then we would go to parse another statement. And since there is a var, probably we'll end up going parsing a declaration. The declaration will do its thing. We know this won't fail because it's tested properly. So after getting out of this, this is the declaration. We return the declaration. We return the statement. Statement is not null. We append the statement to the list of the statements. We advance. Then what's the current token now? The current token is 2. And then after advancing, the current token is a closing brace. So we go out and we advance the current brace. And we set the statements to statement. Then we get out. We get out. Then we go back. And the statement, the current statement is another. It's a block statement, which is good. We advance. Is this after advancing? So the lexer dot next. So the current token is a var. All right. So what statements we have? So we have 0, which is a block statement. Yeah. But this one, I don't think it's gonna be a block statement because we kind of skipped it. Yeah, we don't want to advance here. I guess we shouldn't be advancing here. That's my gut feeling. Yeah, that was the bug. We have an expression. All right, let's go back to the test. Now it'll probably work. Let's see. Yeah, now it passes. Yeah, we just should have been like advancing. Now I want to try out an expression, a statement that actually is followed by something, an empty statement. I won't have anything else. Which is legal, I guess, right? And I want to have some statement which is followed by another statement, and it's So let's do a. I'm trying to find like the simplest declaration statement. Let's do one because I know. So let's do this. I want something that I have already. Yeah. So let's run all of our tests. Yeah, everything still passes. I want to try out. Probably it's a good idea to kind of align these things. A bit toily, but yeah, let's run the tests again. Probably would be a good idea to commit this. So let's try and do that. We added a law comparison operator support. And a block statement. Yeah, just commit that, don't do anything. Okay, still no questions in chat. Either I'm doing, like, people are already sleeping, or I'm doing so good, a good job in explaining, like, what I'm currently doing. Alright, let's try. Let's try and now let's try and add the dreadful if statements. If I remember correctly, if statements are not as complex as we did before. I can either do a loop construct or an if statement. Because for time reasons, I can only do one of the two. Which one do you guys like? Do you want me to try the for loop or try the if statement? Because I suppose now we have what it takes to make any of them. What do you guys think? Alright, so no one is actually responding in chat. So I guess I'll do. Let's try with the if statement. Looks simpler. Let's go to our test. Test parse. what's the convention? Parse something, yeah. Yeah, it's good to make conventions for yourself. Makes it easier to know what to expect in tests. Yeah. So again, I'm gonna steal the boilerplate from somewhere, probably just from here. And I'm gonna remove everything else. And let's try the simplest possible if statement to start with. So let's say we have if this is an if statement, I guess. It's a pretty simple one, so to say. That's too much. And this will start off with an if statement. And we will have something of a binary expression with a literal. How do we test binary expression? Yeah, something like this, and the literal is this. Too few values. All right. And I'll have an identifier expression, which, if I remember correctly, had a name, and the name is A, and the number expression, which is 1. And here we'd have a block statement, and that's it. This is the expected tree we would have. We will want to have an if declaration, some kind of statement, and a block, which is the then block. Yeah. So let's create this if statement. Let's go to the nodes and add that again. So it's type, so an if statement, struct. This struct has the then expression, which is what happens if this actually existed. And then it will have the else expression. I'll call them then and else. And this is, so then is not an expression actually. It should have like the test expression. And you should have the then, which is a block statement, I guess. And then it should have an else, which is a block statement. This can be empty. Eventually, the else statement can be empty. We can have a declaration such as we had before, because it has an if statement, but doesn't have an else. An if statement can be like. So actually, to be fair, this can be also as well. We can have an if statement that does anything, that does nothing. An if with an empty body block, and it's fine. So let's implement. So an if, we can make it either an expression. Let's say like something equals if this, and then the blocks should return expressions. This will make us change the block expression itself, or the block statement, to be an expression, or go the easier part, such as C, and then make the if statement not an expression but a statement itself. I guess we'll go with that in this case. Oh, what the hell did I do? A statement. Yeah. So again, in our visitor part, we do like visitor dot visit if statement. And for this, we'll just return if statement. And I won't care, I won't bother with the other one since those are just marker methods. Visit if statement. And now we should do the same for here. So visiting an if statement is just print indent and say if the buffer by string, we are in an if statement. And if p dot if statement dot, yeah, should write out the test actually. So let's do this. The test can't be empty, and this is for sure. So we know the test can't be empty. So we'll write we'll do p.test statement.test that accept p, and if, sorry, say the statement dot then is not null. It's not a pointer type. This is icky. So let's empty block. Let's make the comparison like really easy. Let's go to the node and make a constant called an empty block statement. What's here? Which is just a block statement that doesn't have anything, and this is a actual eventually. This is just a block statement that doesn't have anything else, and statements are just statement. Empty block for AST nodes when the block statement is optional. We use this instance is used to make the comparison easy. I guess make it easy. So here, this is a parser that empty block. Oh. So the empty block is a block. Yeah, it's an empty block. It's a block statement. Then here we have, you can make it like this and make it shut up at least. Or I would prefer the other way around. making this one a simple block statement. Now, why are you? Oh, the operator is not defined. Huh, really? Interesting. So they should be. So if I want to compare them, they should be pointers. Interesting. I didn't know this. So if it's not an empty block, or which this is completely ridiculous, then dot accept. And dot accept. Yep. Right. Let's do the same for our testing visitor. So the testing visitor, honestly, let me change this to go point to something real. So this is the block statement, and we'll do this as well. And what I want to do is like, if a block statement is empty, or probably I'll just ignore it. So let's do an if statement here. I'll scale this to an if statement. And assert that this is okay. And we do the test, the if statement dot test dot accept. The if statement, the current visitor, and we do the same with the then and with the else. Right. Now, running this, so the then should be accounted for, even if it doesn't exist. If this proves to be too cumbersome, I'll have to change it. But adding just an empty block at the end doesn't seem too bad. So we don't know how to parse ifs, and this is the thing that's need to be implemented, is to actually know how to parse ifs. So since if is a statement, we'll do the same here by like saying, hey, if you have a case, hello Salah. No, you're not. Usually stream for 2 hours. And I'm still left with like a couple of between 30 and 45 minutes of streams. So I delexer if statement, return p.parse. Parse if statement. And let's go create that. So how do we parse an if statement? So we know like we want to create, so we want to create this in parts. So I want to have a quick utility function here, new if statement, because every time we create the if statement, I want to create an if statement that kind of references, I want the test to be empty, So I will ignore it, but I want the then to be empty block. And same for else. Yeah. And since this is only, I guess, for my own convenience, I'll leave it as a private for now. So we know that we are going to parse an if statement. So the first thing is the if, which is, so let's create a new if statement. So this is the statement. And we want to advance because we are at an if. Let's do an expect advance, advance expect. So the current type is if. And the next thing is an expression. It's the test expression, if test, if statement dot test. It should equal to p dot parse internal with lowest. Low? No idea what I called it. Minimum. Okay. Minimum. So let's say we created the test part, which we'll call parse internal, which will eventually parse some kind of expression. I guess this is the call to the expression. This is the first call to parse an expression. Yes. A good idea is to do this, since we don't have to deal with it. A parse expression. And if statement that then should be p dot parse block, I guess. Yeah, we have a block statement. Right. As block statement. Why am I returning a statement? Oh, all right. I guess if I return a block statement, nobody will blame me. Nope. And cannot use this. All right, that's fine. And if the next, now only if there is an else. So if current token dot type is equal to else, only in that case we go and then parse the then statement. So we advance and we call the if statement dot else equal p dot parse block statement. And I guess that's it. And then we return the if statement. So let's see how this turns out. So let's write in for this the smallest if. So if a equals 1, the same that we had for tests, it blows up. So we expect something and then we get 1. All right, so we parse. So this blowed up in the advanced expect, I guess. Yeah. When trying to parse the block statement. Right. So I'll block here and I'll try to run it before actually calling it. So what's the expression for test? We got the left, we got the right. If a is equal to 1, great. What's the current token? For some reason the current token is still 1. Why? Yeah. p.expect next. So what does expect next to? It expects on the next token type to be something, and then it advances. Okay, we need something like this. We expect the next one to be lexer.open brace. Now this should still work. Yeah. So we got a root node, an if statement that has a visiting a binary expression, which has a equals 1, and then two block statements are the then and the else. I wonder if we can do something about this. Probably can change the visitor to add a couple of things. Actually curious if we can do this. This is not cool. So prefix expression, parenthesized expression. Just keep it as a root node. I don't need the visit and stuff. Yeah, probably if I do this, p.buffer, I write string else. Let me do this. These are kind of meta information. Yep. So this is the then part. Do I want it to be printed like this? Yeah, I don't really matter. It doesn't really matter. I wanted to just see where is the then part and where is the else part, and that's fine by me. If we need some adjustment, we'll do it later. So let's go back to the test and see if the test actually passes. It should actually. It doesn't. Where are you blowing up? Here. Probably here. Really? So the last panic was from here, as in like test didn't have anything. Let's see. Parsing an if statement. I don't really care about this now. So let's see test. Alright, it keeps on turning. Yeah, this is taking forever. Why is it taking forever? Oh well. Your if statement is parsed as a logical statement. Can you clarify that? What do you mean by logical statement? Let me see the test. I'll block here and see the root node. The root node generated a bunch of statements, and the first statement is an if statement. The test is what you'd expect. The then is an empty statement, and the else is an empty statement. The parsing is actually correct. Logical expression. If you mean the test should be a logical expression, it doesn't matter, because I'm not doing any checking for now. I'll wait until the next phase. So the parsing here, if this is a logical operations or not, I don't really care. If this produces a Boolean or not, this should only parse as an expression, and otherwise it doesn't really matter. Okay, so what's wrong? The problem is running this blows up, and I have a null pointer. Oh, yeah, right. Why? I don't care, actually. I need this statement. This is why this blows up, and I only care about the type. Yeah, now I have something else. The references of something, parser test, identifier, is my expected tree correct? So I have a binary expression. Nope. This should be it. Incorrect. Yeah, now the test passes. What is a silly bug? So let's do a test with an else statement. I actually want to see the tree with an else statement. Does it actually parse, or I'm just gonna waste a test for it? I shouldn't change much in the tree. Yeah. No parsing function found for else. Right. Let me go back to the parser and see. After parsing the block statement, again, I should expect next, closing brace. And if I do this, what? Actually, expects advance expect. Yeah. So this is the then part. This is the if part. Pret parser is not nice to write. Let us do another expression here. 12, so to say. Yeah, in the else statement, in the else part, we'll see that we have a block statement. So let's write a test, a similar test. What's the difference between advance expect and expect? Yeah, expect doesn't advance, it just throws. But advance expect, it tests. If it found something different, it blows up. Otherwise, it advances to the next token. They can be. I could be using only one and not the other. But since both of them are private methods and just utility functions, if I do another round of refactoring, I will probably catch that one of them is not used and I will remove it. Yeah. I hope this answers your question, I guess. So let's write another test for this. I'm gonna write a statement here. Let me pick the statement I parsed before. What's the statement I picked? So before I had something like a block statement that has one declaration. I'll copy that because I'm lazy. And this is the first block statement. And this is like if clause. This is var a equals 1 plus 2. And we have an else that doesn't have anything in it. And we don't care actually. All right. Okay, this blows up. Is it because I have a wrong tree? Let's see. So I have a block statement. Why do I have two block statements? Only one block statement. No, not that. Wrong test. So I have an if statement with and I have an identifier expression, a binary expression, a number expression. Then I have a block statement with a declaration statement that has a that is equal to do I test for var? Yes, I have tests for that. The tests for that are like the declaration statement. It should be parsed as a declaration statement, but it's not the main goal of the test. So if I find a declaration statement, I suppose that it's working correctly because I have other tests that tests var in isolation. Okay, so the tree is probably correct. 1 plus 2. Yeah. And then we have the else block statement, so it's probably somewhere else. Probably have a bug in my code. So where is the current bug? All right. I don't think. And sometimes I do some dumb stuff. Actually. Yeah, now the test passes. That's probably Yeah, I wanted parenthesized expression in there, so I'll do that. I don't want it to break because I have, oh no, copied the wrong thing. So if I have do the same, and in this case I have, before that I have a parenthesized expression, and I have an identifier that is equal to another identifier expression, which is B. And then I have a block statement. And then I have a declaration statement. This is probably true. Alright, it still passes. What else? Yeah, so the if statement was the last thing on the agenda today. We still have like a couple of minutes to do some stuff. I'm not sure what should I do. I'll probably go around in the code, see something else that I can change. But eventually, I'm not gonna change much, I guess. Because we need to start thinking about error handling, which we are just panicking everywhere here. We need a way to gracefully handle errors without actually like blowing up, and we need to think of a way to kind of do this in a way that integrates nicely with the constructs that we have for now. And also, so I want to make probably I'm gonna make a stream dedicated to error handling, so I won't bother with error handling for now. I will just try to look for stuff that I don't actually need. Yeah, we wanted to have I will need to port the language to a function-based language and not a statement-based language. This means that simply that it's not gonna be a functional language, so to say, but it's gonna be the top element is gonna be always a function. So you won't be able to write var a equals 11 and so outside of the scope of a function. This will make it easier to compile into something else, or like to generate code for other stuff, because like probably every other format that you want to compile to supports functions and such in a way. But for interpreter, if you want like to keep it just at the interpreter level, I guess statement-based languages are not too bad. Like we could have like written like something such as Python, and it will work nicely. But we want something that we can compile like easily, or at least easier. Let's say so I have parse numbers, identifiers. I feel like I have some function here that is defined as public. Yep, this is the one. I wanted to remove it. Parse block statement. All right. So I have advanced expect. Let's see where we use it. Where we use finder. So we probably use it in a bunch of places. Do we have, where's advanced alone? We actually use advanced alone. But should we be using advanced alone? I don't think so, because we are always expecting something. Yeah. I guess in this case, a statement, when calling advance, a statement is always expecting something. So either we expect a closing brace, semicolon, or something else, or an end of file. Yeah, we will need advance. All right. This was put in the wrong place because both of them are. Here, I want to keep utilities at the bottom. This should be parse Boolean. I guess we can commit this. So let's try and run all the tests. Make sure that we didn't break anything. Oh right, something broke. Should be true. Which test is this? All right. One of the things that we added today broke for some reason. In which function? Block statement. Good thing I ran the test before, like actually stopping the stream. Should be true. And this is in parsing block statement. All right. Let's go to parse block statement and see. Inspect the errors there. Test block statement. This is the one. Let's try to figure out which test actually blow up this function. Yeah, just here. Declaration statement. And what's the current source statement? What was the actual test? The test was var a return a. It was this one. And we had an exception such as the current statement so the current declaration statement is not what we expected. Okay, why is that? So we had A and then we had B. Interesting. Current node is 1. Okay. Let's do this. So it's not the first, not second, probably the third. All right, so let's see what the root node generated. Statements. The first one is a block statement. and we have three things. Yeah. The first block statement contains statements, which is a simple declaration. The second one contains the same. One plus two, and so those are the statements, and this was a return statement, which has a return a. Alright. Everything seems okay. So the parser generated a correct tree. Like, I wonder. Oh man, come on. Come on. One, two, I guess this is the one. Nope. This is the one. I'll have to step through. Statements, accept. I don't care about this. I only care about what's actually in the test. An identifier expression. This is where everything blows up. Current declaration statement, identifier, literal. It's null, and Boolean is false. And the current node is a number literal expression. Why is that? Well, this is not good. How do I get to a declaration statement? So the statement has var a equals something plus something, which is a plus 1. Right. And this passes. So this is a block statement. The second block statement had t with pointer 6 in the expected. And 6 is a var token with no expression, which is fine, I guess. So OK is false because the current node is something that is a declaration statement, probably. Yep, has a literal of B, and I tried to cast it to a literal. So probably I'm not incrementing these correctly. So every test should kind of increment. So the index is wrong here. When visiting the block statement, all I can see is like the index is wrong. So the block statements, we have the first block statement, we have the second block statement, and for the life of me I can't see the third block statement. Not here, but here. This is blocks first, second. Where's the third? Oh, come on, don't tell me that's the bug. And how did it get you moved in the first place? Come on. That was stupid. I don't even know how that got removed. So all of our tests pass now, which is good. So I'll just commit this. And if you guys don't have any questions, I guess we'll just call it a day for today. We added a, what's the last thing that we added? We added a if statement support. That's what only 2 T's. Yeah, we changed in all of them. I have to-dos. Yes, I have to-dos probably. If you guys don't have any questions, I guess we'll wrap it up today. We are almost at the 2-hour mark. Thank you guys for keeping up with me, like trying to debug this. And yeah, I guess next week we'll be doing like a little bit more of the last type of statements that we have in Comet, which is like for loops, and we will do parsing for functions. All right. See you guys in the next one. Bye.